listening at home, hi Jenna. We are just about to start. Please stand. In the name of the Father, and of the Son, and of the Holy Spirit. Amen. Saint Michael the Archangel, defend us in battle. Be our safeguard against the wickedness and snares of the devil. May God rebuke him, we humbly pray. And do thou, O Prince of the heavenly host, by the power of God, cast into hell Satan and all evil spirits, who prowl about the world, seeking the ruin of souls. Amen. In the name of the Father, of the Son, and of the Holy Spirit. Amen. I'm going to grab my computer. So yeah, have 7C-1 out. I'll check those off momentarily. We'll read out some answers in a moment as well.
Yeah, that's what I was trying to do.
See what you got. Get those ready tomorrow.
I thought it was pretty funny at the end, just because like we all had
And that was all of us.
marketing ploy.
Hold on, Mosey. It's coming out. I'll see these. I think they're going to be
Michael's like, I said, what's Michael's name? That's right, I can see. That was 7C.
No.
I'll see you.
I really weird when you learn how to do the 11 to the 20.
Yeah.
And I did send out an email on one.
I did not. We can get right tomorrow. And we'll go through a few of those, I think. Anybody else I didn't catch? Okay. All right, grab your red writing utensil, have it at the
He
ready.
isn't calling me Moses all the time.
Yeah, him. Start out in one, gentleman in the back. Solutions are as follows. Number one. This is going to be theta equals, and there are usually two solutions, sometimes there's one. And please make sure these are in degrees. Number one, theta equals 45 degrees and 135 degrees. 45 and 135 degrees. Number two, theta equals 60 degrees and 240 degrees. Number three, theta equals 120 degrees and 300 degrees. Number four, theta equals 30 degrees and 150 degrees. Number five, I'll just give you the numbers, but make sure they're theta equals and make sure they're in degrees. 0 and 180. Number six, 135, 315. Number seven, there's only one solution, 90. Number eight, 0 and 180. Number nine, 60 and 120. Number 10 is only one solution, 270. Number 11, 60 and 240. Number 12, no solution. 13, 150 and 210. Number 14, 150 and 330. Number 15, 0 and 180. Number 16, 30 and a 150. Number 17, 0 and a 180. Number 18, 0 and a 180. Number 19, 30 and 150. And number 20, 60 and 300. And you repeat, Tim.
Can you repeat 14?
14, 150 and 330. Any other repeats? So wait, 1 and 8. Right. Number 1 is 45 and 135. And number 8 is 0 and 180. Yeah.
And repeat number
10 was one solution, which is 270. Any other repeats? Alrighty, questions? Yeah,
10. Can you do number 20?
20, definitely. Oops. So, let me get some space here real fast. 4 minus 4 cosine of theta equals 2. Now at this point, you should be getting a little more comfy. Jack. You should be getting a little more comfy of seeing sine of theta equals 1/2 or cosine of theta equals radical 3/2 and knowing what the angles will be. So sine is up down, cosine is left right, tangent is slope, and you should be able to recognize the common angles when you see the fractions that come from the SOHCAHTOA. So first thing I would do, add the opposite. The chore on this, and by the way, Michael, this is answering your question. Get cosine by itself. Cosine of theta by itself. Actually, Michael, help me out here. What would you get rid of first? Yeah, as long as you do it to
Both sides.
both sides. What do you get so far?
-2.
Well, -4
Oh, -4 cosine.
cosine of theta is equal to,
-2.
good, keep going.
By my -4.
Good, on both sides. What do you get?
Cosine theta equals 1/2.
That should look a little more familiar. Now you can stop and draw a unit circle. Common or uncommon? Cosine of theta equals 1/2. Common. Does that look like a multiple of 30, 45, or 90?
30.
30. Why do you say that?
Because that's what you usually get for cosine of 3.
Correct. What angle are they talking about? Is cosine left, right, up, down, or slope?
Left, right.
Left, right. Is this left or is it right?
Right.
How do you know?
Because it's positive.
It's positive. Is it positive a little or a lot?
A little.
A little. So where are we?
30.
30 would be a lot. If you're over a little to the right, over a lot would be 30. Over a little would be what? They're all multiples of 30. Yeah, 60, and then where's its mirror image?
Just 300.
300, nice. You got your two solutions. So you do theta equals 60, theta equals 300. And that's how you do it. Does that make sense? That's pretty much how you do the back 11 through 20. Yeah. Yeah.
We go to 19.
19, yeah. 1 equals 3. I forgot what it was already. Minus 4 sine of theta. Okay, go for it. What do you do first? Oh, yeah, the opposite.
Subtract 30.
Definitely. What do you get so far?
And then you have -2 equals -4 sine of theta.
Good. Keep going.
And then divide by -4.
Good. What does that give you?
2.
All the way around, we do.
1/2
1/2 equals.
sine of theta.
Does that look like common or uncommon? Common. Where are we?
Is it 30?
It is 30, and it's also,
Um,
what else is that same height?
150.
You got it. Those are two solutions. Theta equals 30, theta equals 150 degrees. Next. Any others you want to see? Does this make a little more sense? A little more comfy, maybe? Okay. Good, because I'm about to flip your brain upside down. Go. Yeah. 13, yeah. I'm afraid so. 13 is negative 2/3. Can you read it off for me? Sophie, can you read it off for me? Huh? Radical 3 over what? 3? Okay. Sophie, help me out here. What would you do first? Definitely. Get rid of the negative 2/3 by dividing. Oops. How do you divide a fraction? What is the reciprocal? 3 over negative 2. So what happens over here? These just cancel. Something nice happens in here. Yeah, the 3's cancel. So cosine of theta, you can just do negative radical 3 over 2. You can put the negative wherever you want. Is that like common or uncommon? Common. Multiple of 30, 45, or 90? 30. Why do you say that? Yeah, radical 3 over 2 is 1. If it were radical 2 over 2, what multiple would it be? 45. That would be from the 1, radical 2. So cosine, left, right, up, down, slope? Left, right. Left or right? Why do you say left? Negative. Left a little or left a lot? A lot. So where are we? 150? You got it. So there's your solution. Theta equals 150 degrees. Theta equals 210 degrees. Does that make sense? Doing okay on this one? If you could do 7 tenths? 17, yeah. Let's see if I get it in. Oh yeah. 3 equals 3 plus a half tangent theta. Which one was this again, I'm sorry? 17. Step me through it. What do you get rid of first? 3. Definitely. How? 9. Yeah, just do it both sides. What do you get over here? 0. Good. Don't leave it blank. Equals? Right. The half may throw people off, but how do you get rid of the half? Divide by it. How do you divide by fraction? Yeah, what's the reciprocal? 2 over 1. Yeah, what's 2 over 1 times 0? Still 0. Common or uncommon? Common. Which shape does that remind you of? 30, 60, 90, 45, 45, 90, unit circle? Tangent equal to 0. There's only one shape that ever uses 0, by the way. Okay. 30, 60, 90 has a 1, a 2, and a radical 3 in it, etc. Anybody? Yeah. The unit circle. The unit circle has 0s and 1s and things in it. So, Julie Sijan, what is tangent on the unit circle? Up, down, left, slope. Is the slope ever equal to 0? Where? 180 and 0. You got it. Theta equals 0 degrees. Theta equals 180 degrees. Why didn't you use 360 degrees? I'm glad you didn't. It's a perfectly legitimate answer. What did the worksheet say to do? Has to be less than 360. Otherwise, I would have included it. 0, 180, and 360 are all good answers. But 360 is too big for what they wanted. Next. Time for one more. Anybody wants it? Did you do this on a test? Going once. Twice. Brain flipping time. Yes.
Can you work
14, if I do it fast, yes. Negative 3 halves, tangent, maybe I can squeeze it in here. Negative 3 halves tangent of theta is equal to radical 3 over 2. We didn't do this one, did we? No, okay. So Michael, talk me through it. What do you get rid of first?
5 by negative 3 over 2.
Definitely. How do you divide by a fraction?
Multiply by root 2.
Right. What do you get? What happens over here?
Oh, so 2's cancel out.
Yep.
Radical 3 over negative radical 3.
Negative radical 3 over 3. Correct. Common or uncommon? Why did you say common? What shape is it reminding you of? 30, 60, 90. Where did the 3 come from? You're right, by the way. It is right. Multiple through.
Where did the 3 come from?
Yeah, because I remember a 3 and a 1, 2 radical 3.
Oh, well, you got radical 3 on the bottom here.
Correct. Somebody took the radical out of the basement for you. So is this tangent left, right, up, down, or slope?
So,
Slope. Is this slope uphill or downhill?
downhill.
Downhill. A lot or a little?
A little.
A little. What would the lot have been?
Just negative radical 3.
Correct. Negative radical 3. So where are we?
So we're 90 and 140.
I'm going to multiple 30 though.
Oh, wait.
Here's 90.
Yeah. 110 and then
110 would be 20 degrees over. It's got to be 30. You're counting by 30s.
So, 150.
150. And then what about over here?
300.
This is 300.
330.
330. Good. So you would put theta equals 150 degrees. And theta equals 330 degrees. Okay. Take out your notes, please. I'm going to hand out the worksheet. Don't panic. This is actually going to be broken into 2 parts. Your assignment first is going to be just the front part, 1 through 6. Yeah.
I wonder if there'd be, like, when you're multiplying, it was multiplied by negative, like, the negative was just in front of the 3 over 2. Like, why wouldn't we put a negative on the 3 and the 2? When you're,
Here, on 3 and the 2.
yeah, like
So
on
like
the
this?
worksheet, like the,
If they're doing like this, why isn't it this?
yeah, because isn't
You
it
tell me.
the same?
What happens with negative over negative?
No.
They cancel and make positive. That's fine. So you can put the negative wherever you want, as long as there's how many of them. I mean, if I just have a negative here, I can put it anywhere I want as long as there's only one of them. Correct. If there's 2 of them, they'll cancel out and make a positive, which you don't want. That would change the
It
number.
wouldn't change the answer if it was
It would
like,
change the answer very much.
no, like, if it was just, the negative on the 2.
Oh, you're talking about this?
Yeah, like, say.
That's perfectly okay. That's fine. Now, the reason I put the negative on top is because it looks more familiar. You could have put the negative on the bottom too. Just make sure it's negative radical 3 over 3. So it's a negative slope and it's a little one. So if you want the negative on the bottom, I have no problem with that. Just don't put it on top and bottom at the same time.
Is the back page going to be due for?
That'll be due the next day. What is it, Monday? Yeah, so the first half is due tomorrow and the second half is due Wednesday. Correct, yeah.
Like, would you just put the negative in front and just confidence people in?
You could. Part of the issue is I'm a little scared of people doing that because if they read it like this, guess what people are going to assume they're going to do? They're going to subtract instead of multiply by negative. So if they do this, course, then it looks like an addition problem. How would we do this? So if there, so I've seen people get so confused here, like the negative sign got so big that it swallowed up the multiplying dot. So there's nothing really, really wrong with that. If you put the negative in front, just be aware that negative in front means the exact same as the negative on top, means the exact same thing as negative on the bottom. It's just not equal to negative on both places. So it's your choice where you want to put the negative, just make sure there's only one. And I think if it's on the top, it's actually easier to use. Partially because if you need to get a common denominator, having an 8 here and a negative 8 here is, it messes people up. So if you don't put the negative on the bottom, then common denominator is easier. Alrighty. Now, if you've taken a glance at the worksheet, you may realize that got a whole new world here. Does anybody happen to remember the 7 basic methods of factoring? From way back when in 8th grade, and we went over it again in 10th grade. Name the first that you always do first. Why do I do that? GCF. What's the next one? This GCF is the first step of factoring. Then, almost. Unfoil. Then, doesn't really matter if you name them in order. Binomial squared.
Grouping?
Grouping is number 5.
Complete the square.
Complete that's different, but you're on the right track. Difference of 2 squares. Then grouping. Then what if you have a funny number in front? Magic pair. And then 7th method, which was optional. Substitution. I want to flash back to substitution for a second. If I do this, go ahead and write that down. Cosine squared of theta minus 2 cosine of theta plus 1 is equal to 0. This should look mysterious. The cosine squared, we don't have a great deal of experience with that. What does it mean? Well, that's actually, the mathematicians of the world got together and decided cosine squared of theta is just a fancy way of saying squaring the entire thing. You might want to make a note of this. Whenever you say cosine squared, it's the same thing as the entire cosine squared. In other words, they did not want it to look like this. Any idea why not? Just visually? Yeah.
It looks like it's just the theta that's going.
Right, it looks like just the angle, the theta is being squared, and that's not true. Like this, cosine squared is really cosine times cosine. Cosine of theta times cosine of theta. Okay. This is just cosine of theta times theta, which is a very, very different thing. So you could look at it like this. Cosine of theta parentheses squared minus 2 cosine of theta plus 1 is equal to 0. And I will ask you to solve for theta, all values between 0 and 360. Now this is enough to start heating up your brain circuits. You start saying, what in the world? We've had some if I had just left this off, I had negative 2 cosine of theta plus 1 is equal to 0. That's something that we did in the worksheet yesterday. I think you get cosine is equal to like 1/2, which is a common angle. What's up with this? Does anyone remember how to substitute? Factor substitute. It's the U equals. The rule for substitution is you pick whatever is the ugliest or weirdest or strangest or most annoying part of the problem and rename it something nice. So, oh, this thing is not equal to cosine of theta squared. These two things are equal, but not equal to this. Okay, they're not the same.
Okay.
U equals,
So you have x. Or I guess if we use u, then we just put in cosine.
Yeah, cosine of what, though?
What?
Cosine always comes with something.
Do it with the square or no? Or just no.
No, just
Just theta.
theta. Let's just see what happens. If it doesn't work, it doesn't work. But the thing that's making this problem so annoying is the cosine. Watch what it looks like if you transform it.
Why do we use u instead of x?
Interesting question. You could use x if you wanted to. I've seen problems that had x in it already, so I wanted to make sure there was a letter that was just, we almost never used. And actually about several hundred years ago, the mathematicians of the world thought the letter u was just awesome. I do not, it makes them, for some really awkward words, you'll find out in about 30 seconds. So if u is equal to cosine of theta, can anybody rewrite this? What is this? Yeah.
U squared
Okay.
minus 2u
Yep.
plus 1.
Can anybody solve that?
And she did that on the square.
Yes, that's a binomial squared. What binomials did they square?
Me?
Square the first, double product, square last. Go for it. Where did it come from? This probably came from what?
U
U.
plus 1. Plus 2.
This is double the product, so
Okay, so -1.
got it. Square the first, check. Double the product, check. Square the last, which is positive, check. Can somebody solve this for me? No.
You do zero product property,
You can do zero product property.
then we get u equals 1,
Okay.
double root.
So yeah, so u equals 1 and also u equals 1. By the way, you can write them both, but you don't have to. It's kind of a duplicate. So u is equal to 1. Congratulations. Are we done? Check Bob.
No,
Why not? What do we have to do yet?
sub cosine back in.
Right. So the thing we learned in kindergarten, when you're done playing with something, put it back where you found it. U equals 1 is the same as what? Go ahead. Ken.
Cosine of theta equals 1.
Cosine of theta equals 1. Is that ever true? Now we've got a problem from yesterday.
That's true, it's
Common or uncommon?
common,
Where are we?
0.
At 0.
Uh,
Anywhere else?
360.
360. And they don't want 360.
Can't. Yes.
So you are done. Does that make sense? You know, some of these problems will require factoring. And do you have to substitute? No, you do not. I'll show you what it looks like if you don't substitute. If you like this, it's actually a little faster. If you don't like it, go ahead and substitute. Everybody look up here for a second. See the cosine squared minus 2 cosine, blah, 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 blah? You can unfoil this right away. Cosine of theta minus 1, cosine of theta minus 1. See what it just did? Cosine times cosine is cosine squared. Minus 1 cosine is this. And then, if you foil it, you'll get this. What I do is unfoil it. I want two numbers that add up to -2 and multiply to be 1. -1, -1. And cosine squared splits into cosine and cosine. Could you do this straight away? Yeah, it'll actually save you a little bit it'll save you the middle step. Then you can set them both equal to 0. And you'll get cosine of theta minus 1 equals 0. Add 1 to both sides. Cosine of theta equals 1. And you'll get the exact same thing over here. So this is a duplicate. You don't have to do that. And then, ta-da. Solve it like normal. See you guys back? I would like to do one of these with you. Pick wisely.
4, 2.
Number 4, number 2.
Do we just put like a sine and a cosine in it? Like 2?
Can we do a sine and a cosine? Yes.
4 is.
I will give you a hint on number 2. Whenever you don't have the same species, can you solve with algebra? No. What do you have to do immediately? Get the answer to 0. I would recommend you do that in every single problem here. Whenever you have sine and cosine at the same time, that's not the same species as cosine. So get the cosine You see the radical 2 cosine of theta? Subtract it to the other side.
Should we do number 4? Since it
Yeah.
has cosine, sine.
Number 2, I'll just give you a hint, there will be a common factor. Go for it, I'm sorry. Number 4, any other votes? 4, okay.
You could do another one, I just thought of you.
I know.
No, 4's there.
Thanks for the rest. 4 is actually one of the scarier looking ones, but let's do it anyway. It's not quite as bad as you might think. Famous last words. We've got negative 3 cosine of theta minus sine of theta. By the way, immediately, these are not the same species. You cannot solve with regular algebra. You must get the answer down to 0. Negative 2 radical 3 times cosine of theta, sine of theta, minus sine of theta. Okay. It's a mess. Tell me how to undo the mess. Got a bunch of different species, a bunch of things. What must we do immediately? Michael. If you can't solve with algebra because there's too many species, what do you have to do? 3 minutes ago.
Yeah.
Get the answer?
Well, does it matter what factor thing you do?
You can't do it yet. Can't factor yet because you got to do something first.
Just yeah.
You can't. That's a type of factor. Can't do that yet. You got to do something else. Pete. What do you have to do first?
Get it equal to 0.
Get it equal to 0. If there's more than one species of anything, stop and get the answer to 0. Stop and get the answer to 0. I don't care which side. Any preference? Doesn't matter. Left side? Okay. How do you get rid of negative 3 cosine? Add it. I'm just going to put that over here. Cancel. How do you get rid of this? Anybody? Add it. Okay. Cancel, cancel, 0. Does anything simplify? Oh, math people.
Positive sine of theta and the negative sine of theta.
Notice? Cancel. Lucky, lucky, lucky. You're welcome, by the way. So we have negative 2 radical 3 cosine of theta, sine of theta, plus 3 cosine of theta. So what do you think? You've got the answer down to 0. What do you do? What? What do you do next?
Well, you can substitute, right?
You could substitute. Let's try it without, just to build up our mental muscles. Does this thing factor? That's the first type of factoring you should always look for.
UCM?
Is there one?
No.
Look carefully.
Yeah.
Theta is embedded, so cosine and theta are like welded together.
Cosine theta.
Cosine theta. It has a common denominator. This is cosine times sine. 3 times sine. Cosine is a common factor. I want to pull out cosine of theta. What do you get left? So cosine of theta times, what's the leftover? Anyway, something on that.
What do you do?
I pulled out the cosine. What's left behind?
Negative 2 over 3, sine theta,
Yep.
plus 3,
Plus what?
3.
3. Good. Now what? Oh, by the way, you see it was leading with a negative? Guess what you should pull out? Negative cosine. Make this positive, negative. Now what? Believe it or not, you're about 60 to 70% done. Something times something equals 0. Is that what I do? Let's say I did this. How would you solve that? No. Zero product property. X equals 0 or x plus 3 equals 0. Do that same trick here. Go.
So
Or,
2 comes first, 2 sine theta,
Uh-huh.
plus negative 3 equals 0.
yeah. Somebody solve this for me? Polly, help me out. I don't have cosine yet by itself yet. How do you get rid of the negative? Yeah, what do you get? Not very dramatic. Cosine of theta equals what? Still 0. Solve this one for me. This is subtracting 3. I'd love to, but there's something further away. This is like 2x minus 3. Yeah, add 3 first. Go for it. What do you get so far? Good. Keep going. Okay. There's something I would ask you to do over here. Definitely. Where? Both sides, top and bottom. What do you get on top? 3, radical 3 over what? 2 times what? What's a radical 3 times radical 3? 3, correct. Now what? Yes, does that reduce? Mhm. Exactly. Sine of theta equals radical 3 over 2, which, by the way, should look familiar. Can somebody solve this one for me? Is cosine of theta ever equal to 0? Julie Sushant. On a unit circle. What is cosine? Left, right, up, down, slope? Yeah, is it ever equal to 0? 90 and 270. You've got 2 solutions. By the way, in this particular one, I think you're going to get 4 solutions. You have 2 solutions from your left branch, and now I just want to see if you get 2 solutions from your right branch. Michael, take over. Radical 3 over 2, common right now. What kind of multiple? 30, 45, 90? 30. Where are we on a unit circle?
Well, it's a little, or no, it's a lot. So it's 60 and it's up and down
Uh,
and it's positive.
uh,
So it's 300.
well, the height, in other words, you said it was, is it up, down, or left, right?
Oh, it's 120. Sorry.
There you go. So if it's up a lot, there are 2 candidates here, 60 and a 120. Those are your other 2 solutions. Theta equals 60, theta equals 120. Sorry, I messed up that. And you just finished the problem. 4 solutions. Does that make sense? So if you can factor this, I would say in every single one of these, get the answer to 0, if it isn't already. Like number 6, Merry Christmas. And number 1, Merry Christmas, it already is. Does that make sense? Get them all, answer equal to 0, and then start factoring. It's a little intense to factor with sines and cosines lying around. But chances are there will be a common factor, or you can unfoil. If you, by the way, substitution is always optional. You can always factor without it. The purpose of substitution is to make it look nice, just long enough to factor. Like it's factoring, u squared minus 2u plus 1 is a lot more friendly on the eyes. But it's an extra step, so up to you. Questions? Okay? Right? It's all yours. Go to it. You have the rest of the hour. We have about 12 minutes. And John, I'll send you a copy of this in the mail. Email, that's on you. So take it in the mail. Yeah, no, 2 weeks later you'll get it. See you later. God bless your health. See you soon.